To all of you. Today we discuss about source coding technique. First, let us know why the source coding technique is very important in communication system. The source coding means assigning binary values to the messages. If you do so, the efficiency of the communication system is going to be improved, right? The most widely used source coding techniques are Shannon Fano coding techniques, and Huffman coding technique. We'll see one by one. First, I start with Shannon Fano coding technique. In Shannon Fano coding, first the messages are written in the decreasing order of probability. Then given message set, say X is partitioned into two most equiprobable subsets, say X1, X2. We have to assign 0 to messages contained in one subset, and we have to assign 1 to messages contained in another subset. The same procedure is repeated for the subsets of X1 and X2. That means X1 will be partitioned into X11 and X12. X2 will be partitioned into X21 and X22. Again, we have to assign 0 to messages in X11 and 1 to messages in X12. So if you look at it, the code word for X1 starts with X11 starts with 0, 0. The code word for X12 starts with 0, 1. Similarly, we have to assign 0 to messages contained in one subset and assign 1 to messages contained in another subset. So if you look at it, the code word for X21 will start with 1, 0. Similarly, for X22, it will be starting with 1, 1. You have to repeat the procedure until you have been left out with only one message in each subset. Again, I'll repeat it. First, you have to write messages in descending order of probability. Then, given message set will be partitioned into two most equiprobable subsets, say X1, X2. X1, you have to assign 0 to messages contained in one subset and assign 1 to messages contained in other subset. You have to partition X1 into X11, X12. Similarly, you have to repeat the procedure. You have to assign 0 to one group, 1 to other group. Similarly, X2, you have to partition into X21 and X22. You have to assign 0 to one group and 1 to other group. You have to repeat the procedure until you have been left out with only one message. Meaning, further partition cannot be done. Let us see one example. Let us see how the efficiency of the system can be improved by going for Shannon Fano coding technique. Yeah, DMS source emits, a discrete memoryless source emits. Eight messages. X1, X2, and so on, X8. With the probabilities 1/4, 1/8, 1/16, 1/16, 1/16, 1/4, 1/16, and 1/8. Apply Shannon Fano coding procedure. Find efficiency and redundancy. Find efficiency and redundancy. First, you have to write the messages in descending order of probability. You have to look at it whether the messages are in the descending order. 1/4, 1/8, 1/16. It's not in descending order. You have to make it in descending order. So what I do is that I'll write the messages probability encoded message and code length. I'll write messages followed by probability of its occurrence. Encoded message, or I can call it as a code word. Then code length. The notation for code length is LK. Probability is, I can call it as PK. If you look at it, the highest among all the probabilities are 1 by 4. So I write 1 by 4 first. That is for x1. So message x1 with probability is 1 by 4. Then you have to look at it, the next highest one. After 1 by 4, you have 1 by 8 here and here. That means x2 and x8 will have 1 by 8. So x2 1 by 1 more 1 by 4 is there. That is x5. Sorry. So x1 is 1 by 4. X5 is 1 by 4. Followed by 1 by 8 for x2 and for x8. So x2 will be 1 by 8, followed by x8 will be 1 by 8. Then 1 by 16, 1 by 16, 1 by 16, 1 by 16. Of course, all are equal. That is for x3. 1 by 16. Then x4, x5. And finally, x7 will have 1 by 16. So first, the messages are written in decreasing order of probability. Now, let me count it. There are 8 messages. 1, 2, 3, 4, 5, 6, 7, 8. X1, this is x6, right? X1 and x6 will have 1 by 4. This is x5, right? Good. Now I have to divide given messages into two most equiprobable subsets. So if I add 1 by 4, 1 by 4, I will have 1 by 2. If I add remaining, it will be 1 by 2. So I can exactly split it here into two equiprobable subsets for which I'll be assigning 0 to messages contained in one subset. So assign 0, 0 for this, and assign 1 to messages contained in other subset. Now you look at it, here I have been left out with 2 messages. As I said earlier, this procedure you have to repeat until you have only 1 message in each subset. So again I can do partition, for which I can assign 0 to one group, 1 to other group. Now if you look at it here, you have only 1 message, so further partition is not possible. If you look at it here, again you have only 1 message, further partition is not possible. Whereas you have here 1, 2, 3, 4, 5, 6, there are 6 messages, I can still partition and I can proceed with further assigning zeros and ones. So now if I add these two, you'll have 1 by 4. If we add remaining, you'll have 1 by 4. So I can split it here. I can assign 0 to one group and 1 to other group. Now you look at it, you have 2 messages in this group, but you should proceed until you have been left with only 1 message. So I'll be dividing further. I'll be assigning 0 to one group, 1 to other group. Similarly, you look at it here, you have 4 messages, so I can split it equally here. 0 to one group, 1 to other group. Now you look at it, you have 2 messages. Further, I have to partition into 2 equiprobable subsets, for which I'll be assigning 0 and 1. Now here I have been left out with 2 messages. Again, I can split it here. I can assign 0 to one group, 1 to other group. Now you look at it, each subset will have only 1 message. That means further partition is not possible. There I have to end the procedure. Now I have to find efficiency and redundancy. We know the formula for calculating efficiency is h of x, entropy of the source, by L bar, average codeword length, where h of x entropy is equal to, given by the formula, summation pk log pk to the base 2, where k varies from 1 to m. Here there are 8 messages, so M varies from 1 to 8. Similarly, the formula for calculating average code word length L bar is equal to average code word length L bar equal to summation Pk into Lk, where K varies from 1 to M. Now I need to find entropy as well as code word length, for which I need to know L bar, that is code word length. If you look at it here, the code word length of the code is nothing but number of bits in the code word. So since I have 2 bits here, the code length is 2. Similarly, here I have 2 bits, code length will be 2. Since I have 3 bits here, code length will be 3. Since I have 3 bits here, the code length for this is 3. Since I have 4 bits here, the code length for this is 4. Similarly, for this, there are 4 bits, so length is 4. Here 4 bits, again length is 4. Here again 4 bits, length will be 4. One thing you can keep it in your mind, when more the probability of occurrence, less will be the bits assigned, less the probability of occurrence, more bits will be assigned. That is the way we try to improve the efficiency of the communication system, or other words, I can say we can try to reduce the redundancy of the information, that is duplicate information. Now let me find out entropy, h of x minus summation k is equal to 1 to 8 pk log pk. It is to the base 2. Normally we use to the base 10 in the calculator. If you want to use to the base 2, if it is log x to the base 2, you have to do log x to the base 10 divided by log 2 to the base 10. That means you have to divide with log 2. The value for log 2 is 0.3010. That means this can be rewritten as to the base 10, provided I have to divide with log 2. That means 0.3010 summation k is equal to 1 to 8 pk log pk to the base 10. Now I have to substitute probabilities and its probability of occurrence. So if you do so, that is P1 log P1 plus P2 log P2 and so on, P8 log P8. The probabilities of occurrence are given 1 by 4 log 1 by 4 plus 1 by 8 log 1 by 8 to the base 10 plus, otherwise you can take 2 times, 2 into, you can do it, 1 by 16. Since I have 2 1 by 8 and 2 1 by 4s, I can multiply directly. There are 2 1 by 8, so 2 into 1 by 8 plus there are 4 1 by 16s, so 4 into 1 by 16 log 1 by 16 to the base 10. If you simplify, you will get the value h of x entropy is equal to 2.75. The unit is bits per message. If might be given as a source is emitting symbol, you would write bits per symbol. Since it is given as message, you would write bits per message. Now we have been found h of x. I need to find L bar in order to find the efficiency of the communication system. The average code word length L bar is equal to, already I have been written the formula here. So now k varies from 1 to 8. So summation k is equal to 1 to 8 pk into lk. Pk represents probability of occurrence of the symbol, lk represents length of the symbol. Already we have been calculated length, already we know the probability, so that, so if it is 1 by 4 into 2 plus 1 by 4 into 2 plus 1 by 8 into 3 plus 1 by 8 into 3 plus 1 by 16 into 4 plus 1 by 16 into 4, 1 by 16 into 4, 1 by 16 into 4. If you simplify this, you'll get average codeword length L bar is equal to 2.75 bits per message. So we have been calculated entropy and we have been calculated L bar. So we are in the position to find efficiency of the communication system eta. So eta is equal to h of x by L bar. Since h of x and L bar are same, 2.75, 2.75 bits per message, we'll end up with eta will be 1. Therefore, percentage of eta will be 100%. Then I need to find redundancy. There is a formula for calculating redundancy. Redundancy is equal to R. The notation is R is equal to 1 minus eta. So here 1 minus 1, it will be 0. That means R will be 0%. That means there is no duplicate information is present in the communication system. From this, it is clear that the moment when I apply coding on the communication system, it improves the efficiency of the communication system. The efficiency can be improved by assigning less number of bits for higher the probability of occurrence of messages and more number of bits for lower the probability of occurrence. That makes my system to be in terms of best, in terms of efficiency. Now let us see one more problem based on Shannon Fano coding techniques. A DMS source, discrete memberless source, emitting 7 messages, say x1 to x7, x1, x2, x3, x4, x5, x6, x7 with the probabilities 0.4, 0.2, 0.12, 0.08, 0.08, 0.08 and 0.04. Find the efficiency and redundancy using Shannon Fano coding technique. Find efficiency eta and redundancy R using Shannon Fano coding technique. As we discussed earlier, we have to write the messages in descending order of probability. Then we have to split into most equiprobable subset, right? So now you look at it. If you add the sum of probability, it will be 1, right? If I can make this as 2 groups. That is 0.4 and 0.2 in one group. The remaining are in one group. That means you have 0.6 in one group and other group will have 0.4. Or I can take 0.4 in one group, other messages in other group. So what happened now? 0.4 in first subset and 0.6 in other subset. So there are 2 possibilities that this problem can be solved. So let me take the case 1 and let me solve it. That means I'll take x1, x2 in one group, remaining are in other group. If you do so, that means I'll write 2 cases. Case 1, I can consider these 2 in one group. That is x1 will have x1, x2. and x2 will have remaining, that is x3, x4, x5, x6, x7. Then case 2, you can have x1 is 0.4 alone in group and remaining are in other group. So x1 in one group. So x2 will have remaining messages, that is x2, x3, x4, x5, x6, x7. Now you have to solve the problem in both the cases and you have to look at it which will lead for better efficiency. Now let us take the case 1. As I said earlier, you have to write the messages in descending order of probability. So have message, probability, then code word, then code length. Code length is LK, probability is PK. So first we have to write the messages in descending order. I think it is there in the descending order, 0.4, 0.2, yeah, it is in descending order. So I have to write x1 first, followed by x2, followed by x3, followed by x4, followed by x5, followed by x6, followed by x7. Write down the probabilities: 0.4, 0.2, 0.12, 0.08, 0.08, 0.08 and 0.04. So first I am going to take these two are in one group, remaining are other group. That is the case. I will have 0.6 here, 0.4 down. So I have to split it here. Assign 0 to messages contained in one subset and assign 1 to messages contained in other subset. Now you look at it here, there are two messages. Again split it, assign 0 to one group and assign 1 to other group. Now you look at it, there are 5 messages here. I have to split. This case I cannot exactly split. If I add these two, I'll have 0.2. If I add remaining, I'll have 0.2. That is the case I can split it here. So split the given message into two equal probable subset. If you add these two, you'll have 0.2. If you add remaining, you'll have 0.2. So assign 0 to one group and assign 1 to other group. You have to proceed until you have been left out with only one message in each subset. Here there are two messages. Again split it and assign 0 and 1. Here you have 3. Here I cannot exactly split, but I can look for most equal probable subset. That is the case. I have to take 0.08 in one group, these two in other group. You should not take these two in one group. If you take these two in one group, you'll have 0.16. This will be 0.04. It is not closer. So I have to look at it where I can make most equal probable subset. That is the case. I have to split it here. I have to assign 0 to one group and assign 1 to other group. Now you look at it, only one message, I cannot split it. Whereas here I have two messages. Further I can split, I can assign 0 and 1. Now you need to write the code length for this. Code length is nothing but the number of bits in the code word. So if you look at it here, you have 2. Here 2 bits you have. So the code length will be 2. Here you have 3 bits. So code length will be 3. If you again here you have 3 bits, code length will be 3. Again here you have code length is 3. Here 4 bits, code length is 4. Here 4 bits, code length is 4. Again you look at it here. Higher the probability of occurrence will have less number of bits, less the probability of occurrence will have more number of bits. That is the way we make it effective in terms of efficiency. Now let us find the efficiency and redundancy. As we calculated early, efficiency eta is equal to h of x by L bar, where h of x is nothing but entropy of the source. H of x is given by the formula k is equal to 1 to m pk into log pk to the base 2. Since to the base 2 we cannot use it in calculator, make it to the base 10, provided you have to divide with log 2. So 0.3010, k is equal to 1 to, there are 7 messages we have, so 1 to 7, pk log pk to the base 10. So we know the probability of occurrence, so pk log pk is 0.4 log 0.4 plus 0.2 log 0.2 0.08, there are 3, so 3 in 0.12 log 0.12 plus there are 3 times 0.08, so 0.03 into 0.08 log 0.08 plus 0.04 log 0.04. If you do so, you will get entropy h of x is equal to 2.42 bits per message. Now let us calculate average code word length L bar. The formula for L bar is equal to summation k is equal to 1 to m pk into lk. We know the probability of occurrence and we know the lk, so L bar can be computed as 0.4 into 2 plus 0.2 into 2 plus 0.12 into 3 0.3 plus 0.8 into 3 plus 0.08 into 4 plus 0.04 into 4. If you compute the value for this, you will get the average code word length L bar is equal to 2.48 bits per message. Now we know h of x, we know L bar, so we are in the position to find efficiency eta. Eta is equal to h of x by L bar is equal to, that is 2.42 divided by 2.48. It will give you the value 0.96032. If I compute efficiency in terms of percentage, it will be 96.032 percentage. Therefore, redundancy R is equal to 1 minus efficiency so 1 minus 0.96032 is equal to 0.0397. Therefore, redundancy or in terms of percentage will be roughly 3.97 percentage. So we have been ended with the case 1. Now let us solve case 2 and let us conclude which way of doing the coding leads for better efficiency. So let us take the case 2 for which, okay, we'll continue case 2 in the next class, or you take it as assignment 2, assignment 1. There you have to make case 2, that is x1 in one group, remaining x2 in other group. You find the entropy as well as average code word length. Of course, entropy depends upon only probability of occurrence, the lead for the same value, whereas L bar is going to vary depending upon the group which you take. If you do it so, you find L bar. If you find L bar, it is going to be much higher than this, so that you can conclude doing case 2 will lead for better efficiency. Please take it as assignment and solve it, bring it. Thank you.
Let us look about the Microstability Criterion. So far, we made stability analysis even in the time domain, frequency domain, and even if we use the root locus also. So this type of stability criterion, stability analysis is completely based on the Nyquist criterion. So first, let us look how the Nyquist define the criterion for finding the stability of a given transfer function, and then we will move to the problem. So the first, let us consider a polynomial, that is the function f of s, which is the ratio of having some numerator polynomial and as well as a denominator polynomial. So these polynomials can be described as s minus z1, s minus z2, and it may have up to s minus zm. Similarly, the denominator polynomial can be described as s minus p1, p2, and then up to pm, where m and n represents the number of zeros. Similarly, the n represents the number of poles. So now this is described in S domain. So we know that S is equal to sigma plus j omega. So every value of sigma and then omega, we can have the S value. So now for this